Hey, this is Dupree here. It's for System Security 2, ISA 4220. We're going to talk about AppArmor and HTTPS. So let's go ahead and dive into it here. Some things that we're going to be discussing is what is AppArmor, how it is used, how to manage profiles in AppArmor, security recommendations using AppArmor. We're going to explain what is HTTPS and how to secure it. Let's talk a little bit about what AppArmor actually is. AppArmor is a kernel level subsystem that works by using a unique policy profile for each of the applications and services that you want to protect. AppArmor is a mandatory access control, or MAC for the abbreviation, system built on Linux's LSM, which is Linux Security Model interface. AppArmor allows a security mechanism that requires AppArmor to be called upon by the kernel for each system to know processes are authorized in a given operation. By this happening, AppArmor makes programs have limited set of resources. So go ahead and dive into what profiles are in AppArmor. AppArmor provides profiles for programs, which another set is just another word or like description for profiles is basically just a set of rules in the program. These profiles are dependent upon an installation path of the program being executed. Profiles are also stored in the -etc-apparmor.d, which I have right here on the screen. Also, profiles are compiled and loaded into the kernel by the AppArmor what's it called? Underscore parser command. Sorry about that. Also, you can use those profiles for each of the applications and services that you want to protect. So basically, like a good example is if someone attacks with a code through Apache. Apache is protected by AppArmor. It is most likely to be safe. Also, the associated profile cannot allow executed privileges. It's a great security defense to use for Ubuntu. Managing profiles after installation, managing AppArmor in general. After the user installs, confirm the installation using the AA status command. By doing that, that will also show the profiles have loaded and are enforced also in complain mode. And these commands allow the user to switch between enforcing and complaining, which I provided for you, which is the AA-enforce command, A-complain, and threw in some other commands there. And those commands allow the user to switch profiles between enforcing and complaining, which is the enforcing complain, and then other commands like disable and audit. AA disable completely disables the profile, and AA audit puts the profiles in audit mode, which seems pretty self-explanatory. I mean, it says enforce, complain, disable, audit. They're just like most commands that I see around now, which can make it simpler on you as a user. Creating profiles. There are two rules used in profiles: path entries and compatibility entries. Path entries are detail which files on application can access in the file system. Compatibility entry determines what privileges a confined process is allowed to use. When you're creating a profile, you want to design a test plan which dividing your test plan into small test case divide your test plan into small test cases. Each test have descriptions. Generate the new profile and use command keys for AA-gen prof. The sudo, I provided the sudo command for you too. Also, the third step is get a new profile in the AppArmor profile package, which is just file the bug launchpad against AppArmor in the packaging. Let's jump into hardening and securing AppArmor. AppArmor allows users to only need to profiles programs that are exposed to attack in the user's environment. Provides immunization technologies that protect applications from the inherent vulnerabilities they possess. Another word for AppArmor would just be immunization. These programs have access to resources that the person using the program does not. So they grant the privilege to the user when it's used. And these are cron jobs, web application, and network agents. Network agent is like a program that can be invoked through a web browser, or a web application is a program that can be invoked through a web browser, and a network agent are programs which is servers or clients that have been that have open network ports. When a program misbehaves, audit messages are sent to log files, which are those command keys I talked about in the previous slide, about AA audit, AA-audit. Program AA-logprof scans log files, and that's the sudo command right there for the AA-logprof. That's the hardening of AppArmor, and I'm going to go ahead and dive into a little bit about HTTPS and what it is. So a little bit about HTTPS is reviews the identity of a website or web service for a connecting client and encrypt nearly all information sent between the website or server and the user. HTTPS stands for Hypertext Transfer Protocol Secure, and in a URL of a website, when it is secure, like another way of describing it is in a URL of a website when it's secured by SSL certificate, which is a secure socket layer, or a TSL, which is a transport layer security protocol. And a secure socket layer SSL just keeps an internet connection secure and safeguard over any sensitive data that is sent between those two systems. And it, like I said, it runs on an application layer and transport layer. The HTTPS connection guarantees three things: confidentiality, authenticity, and integrity. The confidentiality part of it encrypts data, connection, and cookies. Authenticity is making sure it uses the real websites, basically. And integrity is data that is being sent and it's not messed with, which you always want to have those three things when you're going through a website. You don't want your data and information being sent out to the wrong person or somebody finding the wrong information about you. And most information is secured that is sent between a client and a web service. You see the HTTPS on any like URL when you're going to a website. It's on the left-hand corner up there. But yeah, it just keeps everything secure for the most part, and acts as a safeguard. Doesn't really let anything go in between and out. Which browsers and other HTTPS clients are configured to trust and see it like a certificate, which I talk about right here. To secure the HTTPS for a site, the user must receive a security certificate issued by Certificate Authority, which is abbreviated CA. To ensure a high level of security, choose a 2048-bit key. Decide the certificate needed. Single certificate for a single origin. Multi-domain certificate for multiple well-known secure origins. Wildcard certificate for a secure origin with many dynamic subdomains. And verify HTTPS pages can be used and indexed by Google. Those do not block HTTPS pages by robots.txt files. They also do not include no index tags in your HTTP pages, and use fetch as Google to test the Google box, which can access your pages. And that's just basically setting up a HTTPS and how to secure it for a URL or a website you're using. But that's just a little bit about AppArmor and HTTPS, kind of a broad spectrum of it. And of course, I got my sources right here. But overall, AppArmor is basically just a really good security, like kernel level subsystem. I think it's pretty mandatory to have to keep desktops and applications protected at all times. Like I said, it was a safeguard, and like I provided some commands for the program that you can use to see if it's installed, to see if it's working, and if things are being executed, how to set up the profiles in AppArmor, and see if any bugs have hatched or any bugs have launched in the AppArmor packages, and offered some hardening situations where you might need in the AppArmor, and described a little bit about HTTPS being used in a URL, just secure websites for a client and a server to be using at any time, so data doesn't transfer to the wrong person or wrong hacker. But yep, that's it. I'm Dupree, and thank you for watching my slides.